courses in not only in main cities but also in Tier 2 and Tier 3 universities. So India, as you know, is a huge country with a lot of diversity, and we have so many languages. So we are also promoting our own indigenous large language models. Sarvam AI is pioneering one, and I think we already have models which can like build applications in our overall 22 Indian languages. We want to take this to overall all the world. So the main emphasis is that AI should be accessible to people all over the world. It should not be exclusive for some few countries or few companies. We want to take it, ensure that it is available, all the applications are available in most of the languages, and also all the people can benefit from the transformative power of artificial intelligence.
Thank you, Dr. Reddy. Yatsuki, we have all learned the discipline and the integrity and the innovation of Japan. With these emerging technologies, especially AI, how are you planning this?
Well, thank you very much for inviting me, and I'm really honored to be here. I'm talking about before I'm talking about the AI itself. I'll just a little bit about background of our tech industry, why we are now here. Back in the 1980s and 90s, Japan was a world leader in manufacturing. But honestly, we missed the boat during the internet boom, IT boom in the year of 2000. Even with the recent generative AI craze, we've been playing catch up with the US and China. We are still great at building hardware, but our software is a bit weak. That's why the Prime Minister Takaichi is pushing for a huge team effort between the government and the private sector. They're looking to pour serious money into 17 key areas like semiconductors, AI, robotics, and quantum tech, so forth. So Japan, the secret sauce for Japan's comeback is to keep our hardware edge while finally leveling up our software development through massive investment. We are also working on building our homegrown sovereign AI. Our real strength is real-world data. Thinking about it, Japan has a gold mine of data from factory floors, hospitals, and nursing care. We can use these data to build a brains of physical AI. By making our domestic AI smarter, this way we are planning to turn the table and lead the pack in the physical AI space. At the end of the day, it's all about people. For the long haul, we need to focus on mentoring the talent, the kind of engineers who could thrive in Silicon Valley, and making sure that they have the right platform to shine here in Japan.
Thank you. Dr. Shivakumar, before I come to data centers and your contributions, which is the big topic now in the Valley, you have been working with countries like Japan and Europe, with Germany, etc. How do companies like yours work in tandem with the policymakers, because the relationship has to work really well?
Deep, thank you. Thank you for having me in this extremely impressive panel. And by the way, I am Sivaram, not Sivakumar. It's good. I love the name Sivakumar, but I'm Sivaram.
I apologize.
That is okay.
Apologies.
Having said that, there is a word that you are going to hear a lot more going forward in the future. It is called the electro-tech revolution. Electro-tech revolution is the hardware revolution that is fueling this AI boom. It consists on one side on the AI infrastructure, the AI factories, along with semiconductors, along with energy, solar, and batteries. This whole set of things are growing up together, powering the AI revolution. And I have been in semiconductors for nearly 40 years, and now I'm running an advanced battery company, and I'll use the battery example. The requirements for batteries are very simple. They have to be safe, they have to be energy dense, they have to be able to cycle on and off, they have to deliver a lot of power, they have to be cheap. Only 5 things. But it is devilishly complicated to do it. So in the electro-tech revolution, the hardware part of it, given that it is both people intensive and capital intensive, we look to our ecosystem partners. QuantumScape, my company, has developed this breakthrough advanced solid state battery that is the future of batteries. However, to be able to take that into high volume and be able to power the last meter of high quality power in a data center, I need the help of the manufacturing capability that Japan has, the precision manufacturing that Japan has. Similarly, when we go into the automotive space, we need the partnership of someone like Volkswagen, who sits with us, invests in capital, and it helps us nurture this industry to go into high volumes. And the way you do it is nothing but relationships. You have to invest in the relationship. You have to make sure the ecosystem works for you and not against you. I am immensely thankful to the Japanese folks who've been my biggest supporters for a long time, as are my German friends who have been helping me in making this revolutionary breakthrough battery technology into high volume.
Thank you. Dr. Pratap, I come to you. Is education still valid anymore? How are we looking at the whole education system when we have students right from middle school all the way to college using ChatGPT and everything else? Before you can even think of changing the books, there's already, far beyond what we can imagine is already there. So in this environment, how do academia and the institutions like yours take on this challenge?
Well, thank you, Martin. And first of all, thank you for inviting me to this panel. Education has been the key driver of human society ever since we have known. The current period is no different. For 7 decades after World War II, universities have been the centers of invention, innovation, lots of things, right? New discoveries. So if we have been giving so much of innovation and inventions to society, reinventing education is obviously something that we are going to do. This is home turf. Today's education is going to be very different from what it has been for last several decades and a couple of centuries that we have known. All the recipes that exist in your textbooks don't need to be taught anymore. Students are better off learning that from the net or from ChatGPT or whatever you have. But you ask any university professor that are you happy with what you teach in your course? And usually you will get this answer that no, I don't get enough time to teach what I really wanted to teach. More emphasis on fundamentals. Why is that? That's because there was no room for it. Now you do. So now there is going to be a need for really, really hammering down on fundamentals. The students really understand the foundational things. And the new foundational things are different from the past. I call AI the new calculus. For engineers today, it is the new calculus. Every engineer, it doesn't matter what area you work in, right? You have to know this. Now Shiva was talking about battery technology. What is it? Is it chemical engineering? Is it civil engineering? Is it mechanical engineering? Electrical engineering? Is it computer science? All of it. So today's engineer has to be much more interdisciplinary, but has to sit on solid foundations. And that's the challenge that we have accepted. So AI is taught as a complete horizontal, the new calculus, as I said, to all engineers. But also looking at how society is changing and technology is making us more insular. There is a lot more effort on teaching students empathy and compassion. I think that that is going to go a long way. So these are the new things in education that we are trying to bring.
Thank you. Dr. Reddy, I want to build on what Dr. Ruth Pratap said. Interdisciplinary education, interdisciplinary workforce. How do you see that in terms of policy and when you're working with countries like US and Silicon in particular, in terms of exchange of ideas and thoughts?
See, India collaborates at bilateral, plurilateral, multilateral level on all aspects, especially in the areas of critical and emerging technologies. So just to give you an example, we have this trust initiative which is transforming relationship utilizing strategic technologies between India and US to promote collaboration between academia, research institutions, private sector and public institutions in the areas of AI, quantum, semiconductors, 6G and space. So we promote exchange of students, faculty, and we also have this joint report which was submitted by the Association of American Universities and IIT Council to enhance collaboration between Indian academic institutions and the US institutions, especially with regard to exchange of students and faculty. And we also, for example, we have this, India recently joined this PAC Silica initiative. That is this is a US-led initiative for the AI overall supply chain, which includes energy, raw materials, including mineral processing, you have semiconductors, foundation models and AI application. This is entire model. This is basically to see how complementarity between trusted partners can be used for developing of AI applications. This will promote trust for the AI developers and also AI vendors, so that it will benefit all the people in all these partner countries. We have 30 partner countries, including US, India, Japan is also member and some of the EU countries. So we work closely with various academic institutions also to promote academia to academic institutions.
Thank you. Since Yotsuki, you talked about Japanese innovation and those who grew up until the 80s. You're great admirers of Japanese innovation. You also acknowledge that we missed the curve in terms of the next revolution around the 90s and 2000s. Now that you know these strengths, how are you building the new workforce? It has to be drastically different to take on the challenges of the new technological world. And that's where I think we'd be interested to learn from you.
Well, it's not secret that Japan is a super aging society, and we are facing a massive shortage of workers everywhere, from truck drivers and caregivers and factory workers, service staff. So we feel the gap, and I'll tell you the exact figure. Our workforce was around 69 million people in 2022, but it's expected to tank to 60 million by 2040. So it is imperative for us to use cutting edge like AI and robotics to fill in the gap. The government is already working on it, and we are now discussing to launch the so-called robot strategies to providing subsidies or get technologies out in the real world as fast as possible. And what's really cool and unique about Japan, though, is how much people actually embrace this tech. in many places, people fear AI might be the enemy. But in Japan, we see robots as a partner or buddies, helping us to make our life better. So this didn't happen by accident. It's in our culture. For instance, do you know the anime Astro Boys and Doraemon? Since we are kids, we've been raised on the idea that robots are friends, or robot helps us in life. So this culture foundation makes a huge difference, and we grew up these stories that social acceptance of AI and robots is incredibly high. While other countries might worry about robot takeover, but Japan is basically saying, welcome to our team. This kind of mindset, nurtured from a young age, and exactly what's going on, help us integrate this technology into our society smoothly. Thank you.
Thank you. Dr. Shiva, I want to come back to the 5 points you mentioned. Data centers are huge. People are focusing on that. Energy is a big issue when you talk about data centers. How does companies like yours, face those challenges and try to provide solutions?
So I was talking about this electro-tech revolution, and one of the pillars being energy, and is dominated by energy production everywhere, but more interestingly, delivery of power. This electro-tech revolution is constrained today by energy and the delivery of power. But if you notice, the lithium-ion batteries today, the entire production, maybe 90% of the production comes out of one country. The materials needed for making those lithium-ion batteries comes from the same country. The equipment to make that batteries comes from the same country. Literally, we say that the lithium-ion battery battle is lost. There is no chance that any other country is going to come and retake that, because that is gone. So what do? What we do is what we always do best, which is to innovate, collaborate, innovate to get to the next step. Data centers provide one of the biggest opportunities to do this. You don't want to put an old generation technology to be a limiter for something that is exploding in front of us. The semiconductor industry is getting that message, and it has gone from being about a $600 billion industry to well over a $1 trillion industry in the next 18 months. The battery industry, on the other hand, as fast as it's expanding, is shrinking in profitability. It's what you call profitless prosperity. That's of no use to anybody. We need to be at the next level. We need to be at the next generation. That's where Utsugi-san was talking about Japan. The Prime Minister of Japan stands up and says, we need to become the leaders in solid-state batteries in the next generation. And that's where we are. I had the chance to go to India and meet with Prime Minister Modi and told the same story. We need to get to the next generation. Innovation is our answer. We cannot keep looking back and say, let me go get the old solar technology and the old lithium-ion battery technology from China. That's not going to happen. Today, for example, lithium-ion batteries use a material called graphite on the anode side. 100% of the production comes from China. Automatically, China puts export restrictions on it, because they do not want to have either an LFP cathode or graphite to go out to China. So what do? Create a battery that does not use graphite, which is the way we are going and doing. The idea here, always the theme, is where there is a will, there is an innovation to be done. Innovation is our salvation in going into the future.
Thank you. Finally, Dr. Mujibta, we know innovation, we know Jugaad better than innovation in India. With education, it's not an unheard story that graduates who go to very good schools who have graduated have been sitting on the sidelines for 6 months to a year trying to find a job, sending 500 resumes, not getting a job. So in these tough times, how are we as the academic institutions preparing the next workforce?
I think, competent workforce doesn't lack opportunities for jobs. It's only when you provide substandard education to students, they don't find jobs. So the main problem is to have universities provide education that really matters, that prepares students for contemporary society and industry. Students who are innovators themselves, who are quick learners. It's not that we are teaching skills that are going to be relevant for, now, even for 4 years, you can have a bet whether it's going to be relevant or not. So preparing students to be complex problem solvers, that's what industry wants to be. Ask Shiva, what kind of engineers does he want? Complex problem solvers who have interdisciplinarity, that approach built into them, right? Who are entrepreneurial, who can innovate, they can do Jugaad plus. Those are the students you want to train, and that's the kind of training you want to provide. That is totally doable. We are doing it. People can copy our model. Because we are a new university, we have the advantage of starting from clean slate. We are doing this. Everybody is welcome to come and copy that model.
Thank you. Ladies and gentlemen, it's a great opportunity. I'm very grateful for the panelists to take their time out of their busy schedules and come and be with us on the stage of TieCon. We try to bring very different people together on a panel and make some sense of where we are heading. Hope you had enjoyed the conversation. Thank you very much. Appreciate it.
Thank you so much for all the panelists. Really appreciate it. Thank you for a wonderful panel, and I'd like to now introduce the next panel.